Hi, and welcome to Jerry's Engineering Corner and the third edition of the demonstration of Porex Virtek's highly reflective PTFE coming from my basement workshop. My name is Jerry DiBattista and I am the Global VP of Porex's PTFE Business Group. Today's demonstration, we will be taking two identical boxes. One, just a standard plain aluminum with three ports that we drilled in it that we will shine a UV flashlight in and measure the UV output with a meter. The other box, same box, we took Porex Virtek's PMR10 highly reflective PTFE, only 0.75 millimeters thick, and lined the inside of the box. We'll do the same thing, shine the light in each hole to see the difference in UV output. Today's demonstration is designed to simulate a sterilization container or disinfection container. We're going to shine the light in each one, and one of the really important things with disinfection containers is avoiding shadowing. Now, shadowing is where you're trying to disinfect an object in there, like for example an N95 face mask, and the mask itself or whatever is in there is actually shadowing the UV energy that's bouncing around inside the container. One of the things that's really important about Porex Virtek PTFE is it's really highly reflective, and it's diffuse, which means energy bounces off in all directions. This here little chart shows what happens at different reflectivity levels and how many times it will be expected to bounce off. What I did was I highlighted the line at 40%. So what that means is how many bounces you would get off of a reflective surface at a certain percent reflectivity before you would reach 40% of energy output. And this top line is 98%, which our product can reach. At 98%, the amount of times is almost 50 that it can bounce around before the energy goes down to about 40%. At 95%, it drops down to about 19. So you can see just from going from 98 to 95 how many fewer times light bounces around. If you had 70%, which is actually a very good number for aluminum, it's only about 3 times, and the energy is down to 40% of its initial energy output. So what we're going to do next is take the flashlight, and notice these really cute 3D printed parts that my son Marcus printed on his 3D printer for the sensor and for the flashlight to make sure that the flashlight is in the same spot every time. And then we're going to shine it in each one of these 3 spots to show the output. By the way, Marcus, my very talented son, who's a second-year engineering student at UGA, is also editing and shooting the video. So we turn our light on, and we'll start at the top, and we'll get a reading from the side, which is about 270, and the bottom front, again about 270. So that's the aluminum. Now, the Porex Virtek. And you can see immediately when I put the flashlight in that the you can just see the amount of UV coming out of the holes. From the side, 2,700, that's 2,700, and the front, 3,800. Yes, folks, that's about 10 times. We'll flip it over to the side. Aluminum box, about 125, 290, and the Porex Virtek, and you can see it light up. 2,300, 2,800. And finally, one in front, the aluminum, about 200, 100, and the Porex Virtek. 2,200 and 1,900. So you can clearly see how much having a highly reflective, diffuse reflective material allows the light to bounce around multiple times into the chamber, really getting rid of almost any shadowing that would go on in the unit. Whereas when you go back to the aluminum, after it bounces and hits around the aluminum maybe once or twice, that energy is completely wasted. The advantages of Porex Virtek highly reflective PTFE are clear. In the readings of microwatts per square centimeter, getting almost 10 times the reading versus straight aluminum. Simply lining the reactor chamber with 0.75 millimeters of Porex Virtek PTFE creates this dramatic results. From the graph, bouncing around almost 50 times versus 2 or 3 times with aluminum. Well, that's it today for me, Jerry with a G.